Hi and welcome. My name is Raphael Taubinger and this video is about IAR Embedded Workbench for RISC-V with the Mi-V RISC-V Soft CPU on the PolarFire FPGA EVAL Kit. So what I have here connected, as you can see in the picture, I have the PolarFire SoC kit that is connected to the I-jet, and it's using a MIPI20 connector. We are also providing the power supply. But this is the setup I'm going to show you in practice now. So I have here the IAR Embedded Workbench for RISC-V open, and including the IDE, we provide ready example projects. And what I'm going to use here is on the Microchip. We have this flashing LED project, very straightforward and easy to use. So if I open the project here, you'll already see that we have all the source code available here, some Hall drivers, but also the main application that's mainly having some loop and blinking LEDs here. You can even interact with the UART if you want. But if you have a quick look in the settings first here, on the project options, we will see that the Microchip Mi-V RV32IM AF it's selected here. We are also using the M and A extensions here. You could even change if you want to use different base instruction sets here. The embedded one, for example, that's very easy. But once you select the device, the IDE will know exactly what's expected on the other side. That makes, of course, the debugging very easy. So I have here the I-jet that's, as you saw in the picture, connected to the target. And once I do the download, I want the application to stop on main with the run to main here to make it easier. So that's what we need here. We could, of course, also do some changes here on the reset strategy if needed, but we keep it as default here, and the interface could also be changed if needed. But the default works pretty well here. So once I build this project, that should be straightforward and be up to date. Great. I can start the download and connect to the target. So it's doing the download, flashing the application to the target. And from here, I end up here on main. So what you will mainly see is that all the options that are available when you start a debug session are displayed here under the view menu. So you have from call stack information, memory, registers, and so on, all available for you here in the watch window. So if you start here with memory, you will see that, for example, we could just type in main here, or just drag and drop some function here. It will take us to that specific address, so you can see exactly what's happening. Once you are in the debug session, you can, of course, step in, step out, so go step by step. You can do this in C level, or if you click here on the right side, you can go step by step in the assembler mode. If you want to go back here, just click again here and then you come back. For setting breakpoints, just click in any line of code here. That's also valid on the disassembly. You can set them on the fly, and if I leave this application running here, we'll see that it's blinking some LEDs. Very simple application, but probably you also want to get some additional information. So if we have a bit more function calls here, for example, if we just step in here, we will see what's happening, and you see the complete call stack here. You can also see the registers. So if you click here, you will see all the basic registers, or even some additional ones that are available. So you can mainly look inside the microcontroller and the CPU here. So as you can see, you have full control of your application. You can really dig in, do the reset, come back here, do the step-by-step, step over, step in, have the application running, break it at any moment here. You can set breakpoints, so that's very, very powerful and easy. And additionally, it's usually very common when you try to connect first time to the target. that maybe the pins are not all connected correctly, or you need to do some additional investigation. So we have the MODIAC, and this is very powerful. If you connect to the target, you could even test some USB speed or quality, but you can actually test here the JTAG. And if we go to the extra options here, we'll see that we have power being okay here and the pins. And if you just look and read what's happening, if I press the reset button, notice that the value is changing. So you could monitor or just double check if all the pins that you mainly need for debugging are correct here. Great. So as you can see, IAR Embedded Workbench has everything you need for having full control on your application. You can connect it to the target, do the step-by-step, do the flashing. So one solution integrated here in the IDE, ready for you. And finally, I would like to thank you for your attention. And if you have any questions, please reach out to fie@iar.com or visit iar.com/risc5 for more information. Thank you.